With this example, we're going to calculate the mean height and the standard deviation for the players that were selected for the Falcons team. The height is our data, which we refer to as x. We're going to find the average height first, so we will need to add up all of the values for the height. We're going to record our total here, and we'll divide by how many students are selected for the team, which is 7. When I add up all of the heights, I find that the sum of the heights is equal to 1,155. So we're going to find the mean, x bar, this is a sample of data, by taking the sum of x and dividing that by n. Okay, so we would have 1,155, and we divide that by 7. We get that the average height would be 165 centimeters tall. So this measure here is a measure for the center of the data. Now what we want to find is a measure for the spread. If we just glance at the data, we will notice that there's quite a bit of range in heights here. Okay, so the standard deviation we can predict will likely be fairly large. So in order to calculate the standard deviation, we start by calculating the deviation. So I'm going to add a column here where we take each data value, x, and we subtract the mean. So we're finding basically how much taller or how much shorter each student is compared to the average height. So Laura is taller, so her height is above average, and we're finding out, by how many centimeters taller is she compared to the average. So we determined that she's 18 centimeters taller than average. Jamie is exactly the average height. So there's no difference. There's no deviation. Deepa is shorter than average. So we're going to find that her deviation is a negative value. And again, that's just indicating that she is shorter than the average height of the girls on the team. So I've done a few sample calculations where I'm taking the data for x and subtracting the mean from each value. So now I'm just going to continue to write the results rather than showing all of the calculations. A few sample calculations would be enough, as shown here. Okay, so we have Colleen, and she is 16 centimeters taller than average. Ingrid is 13 centimeters taller than average. Justice is shorter by 11 centimeters on average. And finally, Sheila, shorter by 19 centimeters. Okay, so we have the deviations. In order to get an average deviation, we could think about adding up all of our deviations and then dividing by 7 students that were on the team. But unfortunately, when you add up all the deviations, every single time, it'll always work out to 0. So what we want to do is square them first, and that way we're getting rid of the negatives. So we end up squaring 18, 0, negative 17, 16, 13, 11, and negative 19. All of the values will have to be positive. So there's no way that the sum of the squared deviations could ever be 0. So we'll add another column here. We're going to show the deviations that we just calculated. That's just x minus x bar. And we're just going to square all of those. So as I said, we'll have 18, and we're going to square that. Well, the next one is just 0 squared, so that would be 0. Then we have negative 17. Let me square that. Like I mentioned, that's going to be positive, of course. A negative times a negative, 289. That's what that works out to be. I'm just going to continue now since I've shown a few sample calculations. So 16 squared, 256. 13 squared, 169. Negative 11 squared, 121. Negative 19 squared, 361. So we want to average these values, the squared deviation. So I'm going to add up all of those, and I'm going to place that right in the row below. So what that would look like is the sum of x minus x bar all squared. Just adding up all of these values that we see here. So we want to find out what the average squared deviation is. Okay, so when I add up all of those values, I get 1,520. We do want to average that. I'm going to take care of that down here. Okay, so I'm just going to rewrite that. We had the sum of x minus x bar all squared, which we just calculated, and we're going to divide that by the sample size. Well, actually, because we used the mean, which is an estimate, and we're now estimating once again, we have to reduce the sample size by 1. It's called losing a degree of freedom because we're estimating based off of another estimate, and that other estimate was the mean. So doing an estimate off an estimate tends to, as we say, we want to overestimate our value by dividing by a smaller sample size. And we do that for samples. For populations, it wouldn't be necessary to subtract 1 for the sample size. For populations, we would just leave it as uppercase N. Okay, so let's look at the formula then. What we found so far was the sum of the squared deviations, and we're going to divide that by 6, n minus 1. Because we squared all of the deviations, and what we're really trying to get at is a average deviation, we need to undo the squaring now. So what we'll do is take the square root of that. And that's the entire procedure. Okay, so we'll calculate by doing the division of 1,520 divided by 6, and we have to take the square root of that value too. I'm going to take 1 decimal place. Normally we would just do 1 more decimal place than we used for the mean. Okay, so what this means in general is that the average height of the girls can be described as 165 centimeters, but basically plus or minus this standard deviation. It kind of gives you a average range of the girls' heights. Okay, so let's take a look again at what our procedure was. We had our data, and we're looking at first finding out the average. So we added up all of these values for the heights, found a total height. We divided it by the sample size to get our average height. Then we're looking at determining each individual's deviation from average, taller than average, shorter than average. And to get an average of the deviations, we need to square them so that all the values are positive. We add them together, and to work out an average, we actually divide by 1 less than the sample size, as you can see. And the reason for taking the square root is because we've squared, so we're trying to undo the impact of the squaring. The squaring was important to make sure that all of our values would be positive. Otherwise, the sum of deviations would always be 0, and we would never be able to find an average deviation then. So squaring is important, but undoing the squaring is equally as important. Okay, so we get an idea of an overall range of the individual's height in the data set. Okay, so I'd ask now that you would try to implement this procedure for the other students on the other team. That would be the Ravens team. So take some time to do that.